Question 3. This question is about intermediates in reaction mechanisms. Figure 3 shows an intermediate formed in the first step of nucleophilic addition elimination mechanism. Complete figure 3 to show the reactants of two reactant species with curly arrows and relevant lone pairs of electrons involved in the formation of the intermediate. So this is just testing how well you know your mechanism. So what we should know is that what we're going to have is an acyl chloride. So we're going to have the CH3, CH2, C double bond O, Cl, partially negative, partially positive, partially negative. And now you've got the oxygen, two lone pairs of electrons, with the lone pair of electrons, H, CH3. And then what's going to happen is going to go from the electrons to the carbon, then from the middle of the C double bond O to the oxygen, and then you're not going to form this, but I should probably mention that you're going to form CH3, CH2, C, oxygen with the lone pairs of electrons negative, the Cl bond, and now the oxygen which is positive, and you got your H, CH3. Right, now this oxygen with lone pairs of electrons wants to reform the double bond, because previously it had a double bond here. It wants to reform the double bond. In order to reform the double bond, CCl bond must break, and then also we could have just put that on the diagram. We were supposed to put it on. So yeah, it's just a lone pair of electrons, and then from this middle of this hydrogen to the oxygen, CCl bond breaks and the double bond reforms. So hopefully it's not too confusing, but this is exactly what we'd put on the diagram. Lone pair of electrons, oxygen negative, oxygen arrow to reform the double bond, CCl bond breaks, and then from the hydrogen, middle of the OH bond to the oxygen. And then that's for 4 marks. And then 3.2, figure 2 shows an intermediate formed in the first step of reaction mechanism of methyl benzene. Complete figure 4. So methyl benzene, so it's just going to be benzene with a methyl group, and here we go. Now we know the NO2, the nitrogen must be positive, which clearly show that the nitrogen is positive, and it's going to go from the ring to nitrogen, and then you are going to form this. I don't know why I did it so far. I thought there'd be more than one step, but it's just this, and then a final curly arrow needs to go from here to there, from the hydrogen. It's always the hydrogen, middle of the hydrogen bond. And what is this called? Electrophilic substitution. Electrophilic substitution. Figure 5 shows a reactant species involved in the first step of mechanism. Complete figure 5 to show the structure of intermediate form with curly arrows involved in its formation. Because you have this hydrogen is negative with a lone pair of electrons, you should, this is a bit of a weird question, but you should know the mechanism just based on that. It's going to be nucleophilic addition mechanism. Nucleophilic addition. And what is going to happen from the lone pair of electrons to the carbon, and from middle here to the oxygen, what you form now is oxygen negative lone pairs of electrons, and it just wants the first step. So, oh yeah, it will not have the lone pair of electrons. It will just be negative. So go from here to here, here. O minus nucleophilic addition, and then yeah, it will be for H plus substituted to become OH, but it only wants the first step in the mechanism. Show the structure of the intermediate formed. And that is the end of question 3.